Hello, welcome to Waka Waka Breaking It Down. We are in the process in Algebra 2 of going from SOHCAHTOA to angles that are larger than 90 degrees, and then eventually to graphs and behavior of sine, cosine, tangent functions. So we're in the middle of it here. We're trying to kind of wrap our minds around when we have different angles in different positions, and then looking at the trig functions in those, right? So we're looking on a coordinate plane, and we're talking about how the initial side of our angles is always at the positive x-axis. And then we go counterclockwise around the circle to end up with a terminal side. So let's say I had, I don't know, let's say 330 degrees. Okay, so 330 would go all the way around like that. And I would have a terminal side like that from my initial side. So that's really is the angle we'd be talking about if it was 330. But in order to find the trig functions of that, we have to start talking about a reference angle and this reference triangle. So we're actually looking at this triangle down in here. This angle down here, which would be 30 degrees, would be our reference angle. We have to look at the positives and negatives of this triangle that we have, because to the right is positive, to the left is negative, up is positive, but down is negative. So if I want to do the sine of 330 degrees, I can do that, but I have to kind of use this reference triangle to do that. So I look at this reference triangle. I know the sine of 30 is 1/2. Like we can imagine this being a 1 and this being a 2. So 1/2, but the only difference in this case is that since it's not really a 30-degree angle, it's really a 330-degree angle. The opposite side is going down, so it's a negative. So the sine of 330 degrees is a negative 1/2. So we have to include that negative sometimes to kind of make up for the fact that it's not always in the first quadrant and things aren't always positive anymore. Okay, so terminology wise, we got initial side of our angle where we started right at the x equals 0. We got the terminal side, that's where our angle stops. And then we have things like reference angle and reference triangles. I'm going to jump to the end of this unit a little bit and try to kind of get you to see where we're going with this. So some of the stuff that I'm talking about in this video will make more sense. So let's take a look at this. This is trying to make sense of what a sine ratio is doing. So we have our triangle, and I'm going to move this. You see the slider is going to move around, and we're going to be graphing the sine function on the right. And on the left, you can see the actual triangle. Let me see if I can get this right to 30, because that's something we know. Okay, so I'm looking over here at this triangle on this left, and I have this 30-degree angle. So I've stopped where, remember, this is my initial side on the bottom, and it always is, it never changes. Right now, my terminal side is right at 30 degrees. So I'm talking about a 30-degree angle. The sine ratio uses the opposite side, which in this case is going to be red, and then it uses the hypotenuse. Now, the little trick that we're doing is that we're making the hypotenuse 1. So we're just going to make this hypotenuse 1, so then when I spin this around, no matter where I'm at, that hypotenuse, this hypotenuse is just going to stay 1. It's not going to change ever. All right, and that's just a little trick to help us kind of see the ratios a little better. Okay, so if, like, we know the sine of 30 degrees is 1/2. So you can see here that it actually says 1/2. Well, why should that say 1/2? Well, that's because we made the hypotenuse 1. So the opposite is 0.5. The hypotenuse is 1. So when I do that ratio, I still just get 1/2, right? I still get 0.5. So we can see that the height of this actually becomes the sine ratio if the hypotenuse is 1. So it's just a little trick we do. So this red value is the sine ratio. It's the height of this triangle that you're making is the sine ratio. It's the side that's being used to make sine. So that's really the key, because as we go on, you'll see that as the angle gets bigger, that red length is getting bigger as well. When you start looking at the graph, that's being graphed out. As my angle gets larger and larger and larger over here, right? So I can back this up. So as my angle gets larger and larger and larger, that red side is going to get larger and larger as well. Eventually, when you get to 90 degrees, the very maximum it could be would be 1. Like you're going to have 1 divided by 1, I guess. And then here's where we're starting to learn something new, is when we jump past 90, now the triangle, like the triangle used to be like over here, right? It used to be this side we were talking about and this triangle we're talking about. And we kind of still are. You can see that the angle we're talking about is still 105 degrees. It's still coming from this initial side, but we're not using this triangle anymore to get our trig ratios. We're going to flip to the other side and we're going to use the triangle on the other side over here. Why? Well, because we've already kind of talked about how the sine ratio, it makes more sense over here, right? The sine ratio is using the height as it's for the sine. It's using the height of that triangle. So when I pop over here, what's the height of this triangle? Well, the height is still just this red value over here. That's still the height. So we're going to just kind of look at this triangle instead, but really we're still just talking about the height of this triangle that we have. It's just not a right triangle anymore. So when we look at the reference triangle, it makes more sense with the trig, because now we are talking about a right triangle over here. And again, the sine would just be the opposite of that angle, which we already know is that red length. And we know the hypotenuse is 1. So whatever that is divided by 1. So I guess that's the focus. Like, this is where we're trying to get to. We're trying to get you to see that as this angle gets bigger and bigger and it goes around and around this circle, that the red length is really what we're focusing on. That is the sine ratio. That's the side of the triangle that really determines what sine is. And when the angle is 0, that red side is really, really small. It's close to 0. In fact, it is 0. And then when we get higher and higher, when we get up to 90 degrees, that sine ratio, or the length of that red side, is close to 1. And then as we go around, it gets smaller, down to 0 again. And then it goes to -1, right? The height of that red side is in the negatives now. And then it works its way back up to 0. So when we want to do modeling of wave functions and stuff like that, sound waves and actual water waves and any other thing, the temperature in the room that repeats itself, this is a sine function. It starts at 0, and as the angle gets larger, the sine ratio gets closer and closer to 1, but then it goes back down to 0, and then it goes to -1 and back up to 0 again. And then as the angle just goes around and around and around and around, this wave function is just going to repeat itself forever and ever. It's just going to go, go, go. That's why kind of those trig ratios kind of repeat themselves and they make waves. This is where it comes from, and that's where we're trying to get to. Okay, so maybe just have that goal in mind as we're talking about it. I can do the same thing for the cosine. Let me flip over to the cosine graph. So now, instead of the red height being the sine ratio, now you can see that we're looking at this pink bottom side is actually the cosine ratio. Why? Well, because that's the adjacent side to this angle, right? And cosine uses adjacent. So the length of that pink side is now what we're focusing on. And that starts off at 1. And then as our angle gets bigger, that side length gets smaller. And then when I flip to the other side, that side length now is negative because the x value is negative. And you can see that happening over here in the graph as well, right? That pink side length is being graphed vertically now instead of horizontally to give us a cosine value. It goes to -1, then it goes right back again. It goes to 0, 0, then it goes up to 1, right? So it starts at 1, goes to 0, goes to -1, goes to 0, goes to +1, as it goes around the circle. So it's doing the same thing as a sine function. It's just that it starts at 1 this time instead of starting at 0. So the two sides, let me go way back. The two sides of the triangle that we're looking at, the height is the sine ratio, and the width or the base of this is the cosine ratio. Okay? So keep that in mind as we go through the activity. That might kind of help you see where we're trying to go with all this and maybe help you put it all together. But we'll start basic, okay? So here we go. For each of the points, and they've graphed a bunch of points over here, you can see we got 4, 3, and 8, 6, and 12, 9, and they have those here in these points. All right. We're finding the ratio of y over x. So they're asking us to do the height divided by the base. Well, which ratio is that? Well, that's the tangent ratio, isn't it? For this angle, that's the opposite over the adjacent. So all of these ratios are talking about the tangent ratio. Tangent. So what's our ratio? Well, this is just 6 over 8. This is 9 over 12. I'm just taking the y value divided by the x value. They told me what it was. So 1.5 divided by 2 and 3 over 4. Now, these all look like different numbers and stuff, which they are. But what you're supposed to notice is that the ratio of these, when you actually divide the numbers, the ratio of all of these is the exact same thing. 3/4 is the same thing as 6 over 8, right? 6 over 8 is also 3/4. 9 over 12, that's also 3/4. And 1.5 over 2 is also 3/4. So all of these are actually 3/4. Is that just magic? Is it what's going on? Well, not really. It's not magic. If you look at this this terminal side of this angle, if I were to drop all of these vertical lines down and make right triangles out of them, right? If I make a right triangle and another right triangle and another right triangle and a little teeny right triangle, it doesn't matter how small or how big your triangle is, right? I can have a big triangle or I can have a little smaller triangle. It doesn't matter how big or small that triangle is, the ratio of sides will always be the same because they're based on the same angle, right? They're all using this exact same reference angle, so they're going to have the same ratios. The sine ratio, the cosine ratio, and the tangent ratios are all going to be the same. So that's why this makes sense, right, on part B. For a different terminal side, for a different angle, then yeah, you're going to have different ratios. But every single triangle on that terminal side or every single triangle that matches that angle is going to have the same trig functions. Okay. All right. So they're just getting on these next pieces, they're just trying to get you to explore that a little bit. So what I talked about already covers part C. They're saying, well, let's up here, you can see we did y over x, right? So now they're trying to get us to do y over r and then x over r. So what's y over r? Well, that's just the sine ratio. Whoops, go away. This is the sine ratio. And x over r is the cosine ratio. So we already did the tangent, and then now we can do the sine and the cosine. You're going to get the exact same. All of these numbers are going to be the same, and all of these numbers are going to be the same. Because it's the same ratio, same trig function on the same angle. So they're going to be the same, right? If I looked at, let's look at this big triangle. If I look at, let's say, the opposite over the hypotenuse for that, and then I look at a smaller triangle down here, and I look at the opposite on that one over its little hypotenuse, as long as you divide those, you're going to get the same number. Of course, the individual numbers are going to be different, but the ratio is going to be the same. All right. And by the way, we use 3 and 4 because that's a Pythagorean triple. And if you're like, oh, I don't know the hypotenuse. Well, I know this is 3. Or sorry, I know the bottom of the base is 4. I know the height is 3. So that's a 3, 4, 5 Pythagorean triple. That means the hypotenuse is going to be 5. And if you don't know that, you can always do Pythagorean theorem, right? 3 squared plus 4 squared equals hypotenuse squared. But you'll find out that it turns out to be 5. So if you solve and you figure it out, it'll be, this is 9 and 16 is 25. Square root of 25 is 5, right? But that we want you to start memorizing the Pythagorean triples: 3, 4, 5, and 5, 12, 13. Okay, so I'm just going to move on. That's just really for you to kind of explore and a little deeper if you need to. All right, so far that was all positive. These are all positive numbers. We're still working in the first quadrant, so everything's positive. Now what happens if we're in a different quadrant and things start to become negative? That's okay. Just think of it as a coordinate plane. Just come over to whatever place you're at, wherever that angle is. And remember, my true angle really is over here. You can see that blue angle they have here, right? That blue angle. That really is the angle you're talking about. It's like we are going to use the reference angle to get our trig functions and to kind of help us think our way through it. But the real angle is this big angle. It's a big angle. It's larger than 90 degrees. Okay, so let's look. This is the same situation, exact same thing. We're on the same terminal side. We have the exact same angle and the same reference angle. These triangles, even though they're different sizes, are whoa, I didn't want to do that. Are going to have the same ratio of sides, right? So in this case, you can see for this first point here. Let's do this one because it's easier. So let me use this one. Let's say I take 4 over negative 3. 4 over negative 3. Well, isn't that the same thing as 8 over negative 6? Right? If I do the tangent ratio, that's y over x. 4 over negative 3. If I simplify 8, 6, it's still going to be 4 over 3. So it's negative 4 over 3. So those are the same, right? Tangent ratio is the same. If I were to do, and that's what they're getting at down here, right? Let's do the exact same thing, but now we're going to do it for something that has negative values in it, right? So you can see we have negative values now. Right, so no matter what, the tangent is going to be 4 over negative 3, and the other ones will be the same. All of these will be the same. All of these will be the same as that. The sine ratio is going to be, now remember the hypotenuse on this is 5. So that's going to be the opposite, which is the 4 over 5. And these will be the same if you simplify them, right? And then for the cosine ratio, which is this last one, it's going to be negative 3 over 5. And again, if you try these other ones, it's going to work out the same. You're going to have negative 6 over 10. This hypotenuse is 10 on this one. This one, this is going to be like 2.5 for the hypotenuse. Yes. Yeah. Okay. All right. So if you do those ratios, you'll see they'll all come out the same. And by the way, the answers, the actual answers are at the bottom of this. I just don't want to jump back and forth and back and forth and back and forth, right? Whoops, I went too far. No. Right, so you can see here it says they all reduce to 3/5, or they all reduce to 4/5. And then when you have negatives, they all reduce to the same number. And you can see that we did Pythagorean theorem to get all the radii for those, or the hypotenuse, right? To get the hypotenuse. Okay, moving on to number 3, up here. Whoa, what's going on, right? So this was all explaining, just kind of, so at this point you were kind of figuring out that, all the trig functions are going to be the same as long as you're in the same location. Here's a little summary, right? The other thing we need to start wrapping our minds around and probably getting used to, because it's going to help us when we start doing graphing like this, right? When we start graphing things, we're going to start talking about the x value being the cosine and the y value being the sine. So if you can start thinking about x and y on the sides of the triangle and using r as kind of the radius of the circle as the hypotenuse, and you can see that over here, right? We got x on the bottom, we got y on the height, and then we have the r for the radius, which is the hypotenuse of the triangle. So no matter where you're at. Okay. So we need to start really thinking about that. We already have definition of tangent, sine, and cosine. Nothing changes. There's no change to sine, cosine, tangent. It's the only caveat, the only little adjustment is that sometimes we have negative values now if we're in a different quadrant. Okay, so for 4, you can see we got an A, B, and C. We're going to be plotting out this point. So in this case, I'm going to go -4. So it's just a point, right? So I'm going -4, and then I'm going to go -6. And what I do is make a triangle right on the x-axis, like this. Let me show you this. I'll show you what some people do. Some people go -4. This is wrong, by the way. Don't do this. This is wrong. And then they go -6. And then they do this. This is wrong. This is not what we're talking about, right? So that's the wrong triangle. Why is a triangle like this wrong? Well, because you forgot about your angle, like what you're really doing. This is the initial side, and this wraps around to give us the terminal side of a big angle. So you got to have that kind of image going on. So when I get my terminal side, it needs to be over here somewhere, right? Like this, I think, is more reasonable. Where this is -4. And you can write it over here, but I actually tend to put it over here to remind me it's the side of a triangle over here that is -6. This is my reference angle. But remember, the real angle is actually this big angle like this. That's the real angle we're talking about, this whole big guy, right? That's the actual angle. We're just using the reference angle sometimes to get to that. Okay, so what are they asking us to do? The terminal side of the standard position, pass through the point, you just draw the angle and blah, blah, blah. Got it. Now we're finding tangent, sine, and cosine. And they just want the ratios. We're not looking for angles yet, but eventually you're going to be looking for angles. All right, so what's the tangent ratio? Well, that's 6/4, but remember it's -6 over -4. Now in this case, though, the negatives will cancel, and this is just going to simplify to 3/2. Mr. Waka, do I have to simplify it? Yes, you do. You're almost in pre-calculus now. You need to be doing this, getting closer to higher order math and not sticking to basic middle school math. Let's simplify. We can do it. Okay, sine ratio. Oh, for the sine ratio, I need the hypotenuse. What's that? Well, let's see here. 3, 4, 5, 6, 4, 6, 10. No, that's not right. We'll have to do Pythagorean theorem. So 4 squared plus 6 squared equals hypotenuse squared. This is 16. This is 36. That gives me 52. Take the square root of it to get your hypotenuse. And that will simplify into 2 root 13. Do I have to simplify it? Well, you should, yes. So 2 root 13. That's the hypotenuse. And I'm just going to walk you through the first one. The other ones you can kind of, we'll glaze over a little faster. Okay, so now I can do my sine ratio. Sine, remember you're kind of looking at your reference angle to do this. So -6. The hypotenuse is never negative. It's always positive. So you don't have to worry about that. So -6 over 2 root 13. This will simplify a little bit. The 2 goes into the 6 3 times, so I can get -3 over root 13. I'm okay with you leaving it like this. Sometimes you can rationalize the denominator and get that root off the bottom, but I'm fine with this, just the way it is like that. Okay, and then cosine, now we're using the adjacent side, -4 over the hypotenuse. And again, you simplify it. Okay, that's going to be -2 over root 13. And I'm done. Those are all 3 ratios of that particular angle. If I wanted, I could grab my TI Inspire. I could do the inverse trig function of any of these values, like maybe the inverse tangent of 3/2, and I could come up with that reference angle. Once I get the reference angle, I can take 180 plus that to get to that angle, right? Okay, if I wanted to find the angle, I could do so. You guys know how to find angles now, you should. So just do inverse trig functions to get that angle, and then you could figure out the whole angle. All right, I gotta delete all this. All right, now for part B, you can see I have a negative y value, but a positive x. So right away, I'm thinking, where's that gonna be? And that is going to be, if you think about it, it's a positive 4 to the right, and then a negative 5 down. So remember, my terminal side goes like this. So we're going over 4, right? And we're going to go down 5, kind of like this. And then that's my angle I'm talking about. What's the real angle? Well, the real angle goes all the way around. What's my reference angle? Well, that's here, right? Okay, so I got 4 and 5. I can do Pythagorean theorem and get my hypotenuse, and then I can do all my trig functions, just like we already did. Don't forget the negative on the 5, though. That goes with it. Okay, so I'm going to jump down the answers and show you that. All right, so here is A that we already did. You can see that angle. They drew it really nicely, right? Here's my reference triangle. Ooh, here's my reference triangle on that one. Here's part B that we just talked about, and here's my reference triangle on this one, right? And my reference angle. But notice where they're putting the green angle, right? That's the real angle. Okay, so how do I do my trig functions? Well, you can see that this turns out to be root 41 for the hypotenuse when you do Pythagorean theorem. That'll be root 41, and then you can just do all your trig functions, right? You can go opposite over adjacent, do opposite over hypotenuse, and adjacent over hypotenuse, and you're done. 90 degrees, is that what this is? Yeah, they're trying to get you to do a 90-degree angle or something, right? So what if this was straight up and down? That'd be really weird. Well, it'll come out in the algebra of what's going on. So if I did a 90-degree angle, what are the trig functions for 90? That's really weird. Just remember the x value is 0, so that kind of that cosine value is going to be 0. You can see it's 0. For the sine ratio, remember that's the height. We could come with but remember, it's the height over the hypotenuse. So in this case, the height and the hypotenuse are the same number, right? It's kind of like you kind of have to imagine a triangle that's almost at 90, but not quite there. And then it's a little easier to see. You can see like the height and the hypotenuse are pretty much the same number. So when you divide those numbers, like 3 divided by 3, you're going to get 1. So the sine of 90 degrees is going to be 1. The cosine is going to be 0 because you're taking the bottom. Let me do that little triangle again. The bottom side of this triangle is like almost 0. So 0 divided by the hypotenuse is still going to be 0. So that's what we're doing there to get 0. What about the tangent? Well, tangent's undefined here because you're going to be dividing by 0. So when we get undefined, what happens? Well, on a graph, that's going to show up as an asymptote. And we're going to take a closer look at that later. Maybe I could pop it up real quick right now. Not to freak you out or anything, but you'll see as this gets close to 90 degrees, as I get past 90, you see how we got an asymptote out of that? Because we're dividing by 0 and we end up with with that asymptote. So this undefined value, right, becomes that asymptote. Ooh, that's really weird, Waka. Yeah, let me go all the way to the end so you can see what this looks like. So this is what a tangent function looks like over here. We'll get to that. We're going to play around with that more. All right, so that was a little tricky one on C, but which you need to be able to do that. But the main thing is like A and B, right? Being able to deal with A and B was really the real main one because we introduced negative numbers to you. All right, I'm gonna move along here so we can get through the material. So it's just more practice, like on number 6. Let me go to the question. Sorry, I got to jump around here if I'm making you dizzy. Right, so it's doing the same kind of thing, but with special right triangles. So you're going to go to 150 and look at the special right triangles on that, which is right here. So there's a 150-degree angle. The reference angle is 30. And we should know that on that, this is the x, this is the 2x, and this is the root 3x side. So when you do your ratios, you can do the ratios like you are used to. The only difference is that now this one is a negative. So that shows up when you're dealing with that side, you end up with a negative value, right, for these parts. So that negative side is really the only kind of extra. But, of course, you have to remember the real angle is 150 degrees. The 30 degrees is only for reference, okay? And just little things like that. So x, 2x, and x root 3, that's special right triangles. Okay, and then there's a whole bunch of practice, so maybe we just look at a couple of these real quick. Let's do number 2 right away, because this one is in the third quadrant, which we haven't looked at really closely yet. So this is 225 degrees. You have to ask yourself, where's that at? And then you have to ask yourself what that reference angle is. So this reference angle, if you think about it right there, that reference angle, if you take 180, right, halfway around the circle is 180. So if I subtract 180 from 225, what's left over is going to be 45 degrees. So this reference angle has to be 45 degrees. Well, if it's 45 degrees, that's a special right triangle. So this I know is 1x, or just x, and this is also x for the legs. And then the hypotenuse is x root 2. That comes from special right triangles. So instead of writing the x's, we just wrote it as -1 because we're going left, and -1 because we're going down. And then we have root 2 is the hypotenuse. So if I want to do the cosine, I take the adjacent, which is -1, over the hypotenuse, which is root 2, and you end up with that. And then that's good enough. So we're making you start thinking about and calculating what that reference angle is. If it's a special right triangle, then just use those ratios. Like you can see here, this one's a special right triangle as well, because that one comes out to be 60 degrees. This one's 45 degrees. This one's 30 degrees. And then they give you the ones that are flat. Like this is a flat one and a flat one. So those are a little harder. That's kind of like the vertical ones that you have to think about, right? So you're just going to be using these points, and the hypotenuse is always going to be 1 on that. So you have your x and your y, and you have your hypotenuse, so you can do whatever ratio they ask you to do. But these, yeah, if it's a special right triangle, just use those ratios. There's not much you really need to do with a calculator or anything. You should know all those, the relationship between all those sides. Now, if it's something else, like the one we did before up here, like 4 and -5, now you're not talking about a special right triangle anymore. You're talking about something you're going to end up with a square root, and it's going to be maybe a little different, right? A little funky. And that's where you start using your calculator to find angles as well. Okay, so there you go. I'm going to leave this one kind of where it is and let you work with it a little bit. I think the main goal is to be able to find your reference angles, be able to plot points and use those to create a triangle. And then the last thing, which is really important, is to use your y value, your x value of your point, and the hypotenuse to end up making all your trig functions. And that's what they kind of tried to summarize here. Whoops, sorry, right here. So kind of starting to think about tangent as the y value over the x value, instead of just saying opposite over adjacent all the time, and saying the sine is the y value over the hypotenuse. Instead of saying it's the opposite over hypotenuse, you say the y value over the hypotenuse. And same for cosine, it's instead of the adjacent now, we're going to talk about the x value over the hypotenuse. So when you have points, sorry, jumping around. So when you have points, all you need to know is what's the x, what's the y, and what's my hypotenuse. And then I can easily do any of those trig functions quickly because I can think about them, right? I can think about this in terms of x, y, and hypotenuse, and I can quickly do whatever ratio I need. Yeah? Okay. So I know it was a little fast on some of this. Hopefully the main points came out, right? Let me get to the bottom again, right? When you have something difficult, where you're like, ooh, this is like right on the x-axis or right on the y-axis, just focus on what's the x value of that, what's the y value of that, and what's the hypotenuse. And it'll come out. You'll notice whether you're dividing by 0 to get something that's undefined, or you're not, and you'll actually end up with a number. That happens as well, right? Sometimes you divide by 0, sometimes you don't, when you're right on the like x or y axis. Otherwise, it should be really obvious. Okay, so things are starting to come together. Yeah, good. Just keep practicing. This does take a little time to get used to it. It's not hard when you get used to it, but to get used to it takes time, right? So be patient with yourself and give yourself some time and just keep working through each of the problems and, kind of start changing your focus to this whole graphing idea, right? When the circle goes around and around, what happens? Okay, we'll talk more about this in the next videos.